Hello everyone, and welcome to the first BC topic that's not covered in AB. Euler's method. It looks like Euler, but it's really pronounced Euler. Euler's method is used to approximate a differential equation that we can't actually solve. And here's the formula for it. So you've got to be given a point, and you've got to be given some sort of derivative. So the next point is the previous point's y value plus plug in the old point into the derivative times dx. Now that seems a little confusing, but if I show you an example, you'll see it's just a pattern that you follow. Euler's method is not difficult, it's just a pattern that you have to memorize. There are many differential equations that cannot be solved. We can still find an approximate solution. Let's use Euler's method with 4 steps to approximate y of 0.4. Well, I need 2 things. I need a point to start with, 0, 1, and I need a derivative, and I have that. I really already know this information because it tells me right here, and this gives me a hint. If I'm going 4 steps to get to 0.4, then I'm counting by 0.1. So, remember, the formula is y sub 1 equals y sub 0 plus f, which is really y prime, of x sub 0, y sub 0, dx. So let's fill in what we know. I don't know what y sub 1 is. I know y sub 0 is 1. My first y value is 1. Plus, this means take the point that you have and plug it into the derivative. I gave you a really easy derivative in this problem, so this one's really easy. Plug in 0, you get 0. Plug in 1, you get 1. 0 plus 1. And dx is 0.1. Now, if you plug all that in the calculator, you get 1.1. So that's the first step of Euler's method. But it says to do 4 steps, so let's do another one. This one's going to be y sub 2 equals. Now, I'm going to use the point I just found for my y, 1.1, plus I'm going to plug it into the derivative, so the y value is going to be 1.1. But let's talk about the new x value. The old x value was 0. And we're counting by 0.1. So what's my new x value going to be? It's going to be 0.1. The dx is always going to be 0.1 in this problem. If you plug that into the calculator, you get 1.22. And that's the second step of Euler's method for this problem. Again, this is an easy derivative because I gave you an easy derivative. Some of them might be more complicated, like 2x plus 3y, and then you do 2 and a 3 there. Let's go to y3. It's the previous y value plus, plug in the 2 points for the derivative. The y value of the derivative is 1.22. What's the x value going to be? Well, it was 0.1. We're counting by 0.1, which makes it 0.2. The dx is going to be 0.1 in this problem, always. That's 1.362. And then let's go with y sub 4, the last one. That's 1.362 plus 0.3 for the x value, 1.362, times 0.1, and y sub 4 is 1.5282. So that's Euler's method, just a way to approximate a differential equation. Okay? You'll have a lot more practice in class on this, so don't panic. Just memorize the formula and be able to follow the pattern. Thanks.